Assalamualaikum and good afternoon. So this is our last chapter for Fluid Mechanics 22323. So it is about the Pelton wheel. So Pelton wheel is one type of turbine. So the previous one is the Francis turbine. So Francis turbine is in group reaction turbine. So we have a reaction turbine. Okay, reaction turbine. So one of the example is Francis turbine. So Francis is a engineer's name. So he designed the system. So and then Pelton wheel here is called as impulse turbine. Okay, so we will learn about another type of turbine that use the different idea. So what is the difference? So we will see in the next slide. Okay, so first, what is Pelton wheel? So Pelton wheel or Pelton turbine is a tangential flow impulse turbine. So the word impulse here, in which the pressure energy of energy is converted into kinetic energy to form high-speed water jet. So and then this jet strike the wheel tangentially to make it rotate. So this is the idea. So we have a water tank, for example, or a dam, or a waterfall, or a river, for example. So we just flow the water into a nozzle. So why we have nozzle here? Because we want to small down the cross-sectional area. So if the cross-sectional area is small, so means the velocity is high. So why we need to get higher velocity at this point? Because we need more momentum to be produced to hit a bucket here and to rotate the wheel. So that is the idea. So as show here, so means that it's changed the pressure. So the pressure means the potential energy here. So you have H. So rho GH is pressure, and then the pressure here will convert it into kinetic energy, and then kinetic energy will hit the bucket here, and then it will rotate the turbine. So and then so the turbine is connected to the generator here, and then it's rotate the generator, and then it could produce the electricity. So who invented Pelton wheel? Pelton wheel is an impulse type water turbine invented by Lester Allan Pelton in 1870s. So you could read this from this slide. So I skip this one. So this is another simple type of Pelton wheel. So this is the water wheel. So I think you know how to build your own water wheel. At least, for example, if the river flow like this, so you could install your water wheel like this, or you could install it like this, or you could rearrange the water and make sure it fall down at the top here, or you could do like this. So this is just the arrangement, but I think you could understand the idea, the mechanism, how Pelton wheels work. Okay, so this is very important chapter. You need to know how to explain the mechanism of Pelton wheel. So the important parts of Pelton wheel is show here. So it is nozzle and spear.
百多几百哦。
So and then we have runner and bucket. So we have a braking jet here and the casing. Okay, so the nozzle and spear is here. So the nozzle is actually the a component, a part which create the water jet. So and then a spear is actually something inside the nozzle to become a stopper for the water jet. So I will explain it later. So runner and bucket. So runner is here. So we have a bucket here. So in Francis turbine, we have blade, and this blade is attached on a disc, and the whole system here is called runner. So in Pelton wheel, so we don't have blade like this, so we have a bucket like this. After that, we will show you the real picture of bucket, and the bucket will attach at a wheel here, and the whole system of this one is called runner. So and then we have a braking jet. So a braking jet is something like this. So it is actually the reverse flow of the water, just because the wheel rotate like this. So and then if we flow water like this one, so it will stop the rotation. So and then the casing. So this is the casing. I think you could imagine the casing of this turbine. Okay, nozzle and spear. So the water from source is transferred through penstock, to which end a nozzle is provided. Using this nozzle, the high-speed water jet can be formed. To control the water jet from nozzle, a movable needle spear is arranged inside the nozzle. The spear will move backward and forward in axial direction. So axial direction means this direction. When it is moved forward, the flow will reduce or stop. And when it moves backward, the flow will increase. So you could understand the mechanism to control the flow rate with the spear here. So when the spear move forward, so it's lock the hole, and then the water will stop flowing. So and then the runner and bucket. So a Pelton turbine consists of a runner, which is a circular disc. So this is the circular disc, on the periphery of which a number of buckets are mounted with equal spacing between them. So the equal spacing is very important, because to make sure that the water jet is hit the bucket continuously. The buckets mounted are either double hemispherical or double ellipsoidal shape. So the double hemispherical means, you could see here. So I will show you another picture of this one. So it's actually divided into two sections. So like this one, if you could see here, so it's maybe separated into two sections. Okay. A dividing wall called splitter is provided for each bucket, which separate the bucket into two equal parts. The buckets are generally made of cast iron or stainless steel or bronze, depending upon the head of inlet of Pelton wheel. So each bucket is divided vertically into two parts by a splitter. So this is the splitter. So you could see here, which is a sharp edge of the center, sharp edge at the center, giving the shape of a double hemispherical cup. So this is the double hemispherical cup. So the splitter is sharpened to ensure a loss-free entry of the water jet into the bucket. So I hope you understand the word loss-free. Okay, it is also helping the water jet to be divided without shock into two parts moving sideways in opposite direction. The water jet is deflected by the bucket at about 160 degrees. The shape of the bucket also carefully designed to make sure the path of the jet is not obstructed by the incoming bucket. So this is a very important point in designing the Pelton wheel. So the idea is, so we have a splitter here, very sharp, because we want to make sure that when the water hit at this splitter, it will split clearly without any losses and without any shock. So you could imagine if your bucket, for example, okay, if the splitter has a cross-sectional area like this, so this cross-sectional area will create huge amount of loss. So means it might be reduce the rotational speed of the Pelton wheel. So this is the real setup of the Pelton wheel. So this is the bucket. So and then maybe you are questioning about the degree of 160 degrees. So the meaning of 160 degree means that, okay, let's say the water is here. Let's say the water is at this one. So the water will hit this, and then it will go to the bucket and it will reduce like this one. So the angle of this one is actually 160 degrees. So I will show you later on in velocity diagram later on. Okay, this is the braking jet. So braking jet is used to stop the running wheel when it is not working. This situation arises when the nozzle inlet is closed with the help of sphere when the water jet is stopped on the bucket. But due to inertia, the runner will not stop revolving even after complete closure of inlet nozzle. To stop this, a brake nozzle is provided as shown below. So this is the brake nozzle. The brake nozzle directs the jet of water of the back of bucket to stop the wheel. The jet directed by brake nozzle is called braking jet. So the idea is simple. Actually, it's come from the same pipe here connecting the brake nozzle. So when the spears go forward, stop the flow, and then the water will flow to this one, and then they will hit the bucket. So you could imagine that the wheel is rotate counterclockwise like this, and then you flow a water like this one, so it will slowing down the movement of the wheel. So means that it accelerates to the time to stop the wheel. So this is the jet, the braking jet, and this is the casing. So the whole arrangement of runner and bucket, inlet and braking jets are covered by the casing. Casing of Pelton turbine does not perform any hydraulic action. So this is the very important terms. But prevent the splashing of water while working and also helps the water to discharge to the tail race. So the idea is the casing here is actually not so important compared to the casing for centrifugal pump and Francis turbine. It is because for Pelton wheel, so it can work without casing because it's working at atmospheric pressure. So means, as you could see, with the water wheel. So water wheel can work if you only have the wheel and also the water flow. That's it. You can use your water wheel can be used because the pressure for Pelton wheel is actually atmospheric pressure. However, the casing here is to make sure that the safety at the dam is good. It is not easy to install or to sabotage the Pelton wheel mechanism, the Pelton wheel machine. Okay, but the idea is it is not perform any hydraulic action here, means the pressure is actually atmospheric pressure. So it is okay to have or to not to have a casing here. So this is the example of Pelton wheel in hydroelectric plants. You could see the bucket here. So and then means the water will flow inside this and then it will flow out like this one. So I will show you later on with, because it is weird when I show you at the top here, the water is not there. Okay, the working of Pelton wheel. The water is transferred from the high head source through a long conduit called penstock. So penstock is actually a system, a pipe system to bring water from the high level to the nozzle. Nozzle arrangement at the end of penstock helps the water to accelerate and it flows out at high speed jet with high velocity and discharge at atmospheric pressure. The jet will hit the splitter of the bucket, which will distribute the jet into two halves of bucket, and the wheel start revolving. So the kinetic energy of the jet is reduced when it hits the bucket, and also due to spherical shape of bucket, the directed jet will change its direction and takes U-turn and fall into tail race. In general, the inlet angle of jet is in between 1 to 3 degree. After hitting the bucket, the deflected jet angle is in between 165 to 170 degrees. The water collected in tail race should not submerge the Pelton wheel in any case. So why it's not submerged? because if the water submerge the Pelton wheel, it will give resistance to the wheel to rotate. To generate more power, two Pelton wheels can be arranged to a single shaft, or two water jets can be directed at a time to a single Pelton wheel. So what is the meaning of two Pelton wheel can be arranged to a single shaft? So we have a generator here, for example. So we have a long shaft. So maybe we have two Pelton wheel at the same shaft, or we just have a generator here. So we have a shaft here, so and then we have a Pelton wheel here. Maybe the water jet is, we put two water jets for one single Pelton wheel. So this is the meaning of this statement. Okay, this is the water jet. So we strike like this. So this is actually the laboratory scale. So maybe you could see that it is not so accurate. So the idea is, this is the water jet, and the water will reflect to the bottom like this one. So the angle here, is commonly it is 165 degree. So this is the reflected angle. So this is what it's mean by 165. So and then the why we have splitter, or why we have double spherical shape, because let me see another. Okay, so this is the idea. The jet will hit the splitter of the bucket, which is distribute to the jet into two halves of bucket, and the wheel start revolving. So the splitter will, the water will hit the splitter here, and the water will hit like this one. So at this situation, so the angle here is 165 degree. So and then we must have the two spherical bucket like this one, okay, to make sure that the water will flow to the direction like this one. It is, first, we don't want the outlet water here will flow at the same direction of the inlet water, because it will reduce the efficiency of Pelton wheel. So and then at the same time, the water here must be the direction of the outlet water here must not hit the next bucket. So the idea is, for example, we have a wheel here, we have bucket here. So if the water hit this one, and the water here hit the next bucket here, so means that it will slowing down the wheel. So all the parameter is need to be think at this situation. So this is the example of Pelton wheel with two nozzles. So the idea is simple. If we hit this one, so the water will come out there, and then the water will flow down like this one. So mean it's not hit the second jet. So this is the second jet. So the water will flow down like this one. So means that the existence of these two jets is not disturbing the mechanism. So means that the wheel could rotate freely. So with that means the losses of the rotation here can be reduced to make sure that the water is not hit the next bucket. Okay, this is the idea, the real setup of Pelton wheel. So this is the Pelton wheel, the runner. Okay, so and then this is the nozzle. So what you could see here is actually the spear. So if the spear is moved forward, so it stopped the water flow. Okay. Okay, this is the situation where we have 5 nozzle here. If you see 1, 2, 3, 4, 5 here. So we could have 5 nozzle, because in this situation, when water hit here, so it will flowing down. So means all the water flow is not hit the next bucket and also not disturb another water jet. So this is the example, Pelton wheel with a multi-nozzle. So this is another example of Pelton wheel used in real industry. You could have this one in your textbooks. So we have a two nozzle here,